Welcome for this time for chemistry practical session, and for today we continue with our experimental questions with their solutions. So today we are in experiment number 4. Our specific objective is determination of atomic mass and to identify the name of the element X. Atomic mass and the name of the element which is unknown. So experiment number 4, you are provided with the following solutions containing acid and the base. So solution C containing the acid, which has concentration of 9.13 gram per decimeter cube of HX. So we are going to determine the value of X. Solution D containing 1 gram of sodium hydroxide in 0.25 decimeter cube of the solution, and the methyl orange indicator we have to use for titration. That is our data for experiment. The questions. The first question, with the static symbols, write a balanced chemical equation for the reaction between solution C and the solution D. Solution C is acid and solution D is base, which is sodium hydroxide. A procedure: titrate the acid in burette against the base in conical flask using 2 drops of your indicator or methyl orange and obtain 3 titer value. Another question, what is the volume of acid required to neutralize the volume of base for complete reaction? So that is a question very important to you. You are supposed to know after titration what is the volume of acid required to neutralize the volume of base for complete reaction. So what is the volume of base and what is the volume of acid? Another question which is very important to you, you are supposed to show the clear procedure on solving this question. To identify the element X is showing the procedure clearly. Identify element X in acid HX or hydrogen X. This question is somehow complex, so you are supposed to think more which procedure you are supposed to start and then which procedure you are going to end with in order to identify the element X, to know the atomic mass and the name of that element. So let's we go in our experiment in our laboratory to perform titration, and let's see. We will see the ending point for the reaction, and then we will see how this question have been solved. Okay, according to our question, let's start with performing titration experiment. Procedure by procedure, one by one, then we will see the ending point for the reaction. I have a base solution or alkali solution. This is our solution. And then we have methyl orange, that is our indicator for titration. And then we have a pipette, that is 25 mils of our pipette, and then this is our burette for the acid, and this is acid solution. Also we have conical flask. So this is a setup of our titration apparatus. Let me see. We start the procedure. The first procedure, we're going to fill a burette with the acid solution. Make sure you fill up to above the 0 in order to fill this tip of your burette. Then now we are going to fill our burette. So the filling burette is ready. The second procedure, we are supposed to pipette our solution. Then after that, we are going to put on a conical flask at the base solution. This is base solution. Then after, we are going to put 2 drops of indicator. 2 drops of indicator. 1 drop, 2. Or you can add up to 3. That is color change. Then let me start our titration. Before titration, you're supposed to note the initial volume. Yes, that is 3.8. Then you start titration. That is the ending point for the reaction, and this color is orange color. Our volume is 10. After performing titration, That is the ending point for the reaction.
I think let's go to the class to see how this question have been solved.
And we have noted the volume. So the answers, the first question, with the static symbols write balanced chemical equation for the reaction between solution C and the solution D. Balanced chemical equation is between C and D. HX aqueous solution reacts with sodium hydroxide, and the product is aqueous solution of sodium X plus water, hence balanced. And the molar ratio is 1 mole of acid react with 1 mole of base for reaction complete. Then after that, before writing the table results, you are supposed to show burette used and the pipette used. Burette used is 50 mils and the pipette used according to our apparatus we have of pipette is 25. Table results is that one. Is saturation, pilot, theta 1, theta 2, theta 3. So you are supposed to consider the SI unit is very important when recording your table. And then you are supposed to record your values into 2 decimal places. Even if you are not asked to show the table results, you are supposed to show your table of the results after performing the titration in a procedure. Are we together? After recording the table results, you are supposed to show also the average volume used, and you are supposed to show in calculations. So the average volume used, we take volume 1 plus volume 2 plus volume 3 divided by 3. We are not using pilot because pilot is a rough estimation of the volume. So our volume used is 10 mils plus 10 plus 10 divided by 3, and the volume of acid used to neutralize the base is 10 mils. Another question, it means what is the volume of acid required to neutralize the volume of base for complete reaction? 10 volume of acid required to neutralize 25 of base for complete reaction. That is the answer for that question. Question number 2. Showing the procedure clearly identify element X in acid HX. Because our question guided us to solve this element X inside of acid. So our first procedure, we are going to determine the molarity of base. Molarity of base is equal to concentration over molar mass. Concentration is the mass over volume. What is the mass? Mass, according to our data, 1 gram dissolved in 0.25 of the solution or the seed water. So the concentration is 4.0 gram per decimeter cube. The molar mass of sodium hydroxide is 40 gram per mole. So according to the formula of molarity is concentration over molar mass, the molarity of base is 4 gram per decimeter cube divided by 40 gram per mole. So the molarity of base is 0.1 mole per decimeter cube. So that is first procedure. Procedure number 2, to determine the molarity of acid. Molarity of acid, use molar ratio formula, which is MAVA and B is equal to MBVB and A. That is our formula. So molarity of acid is required. Volume of acid is 10 mils from the titration experiment of volume used. Molarity of base is 0.1 mole per decimeter cube. Volume of base is 25 from the pipette. Number of mole of acid is 1 mole, and the number of mole of base is 1 from balanced chemical equation. Molarity of acid is MBVB and A divided by VA and B. So MA is equal to 0.1 times volume of base 25 times 1 mole of acid divided by volume of acid times 1 mole. So the molarity of acid solution is 0.25 mole per decimeter cube. So after performing that molarity of acid, procedure number 3 is to determine the molar mass of HX. So in any question of volumetric of determination of a known element, you are supposed to have the molar mass of whole compound in order to get the unknown value. So molar mass is the concentration over molarity in unit mole per decimeter cube. So mass or the concentration is the mass over volume. According to our concentration of the acid is 9.13 gram per decimeter cube. So the molar mass is the concentration over molarity. So concentration is that one, 9.13 divided by molarity 0.25. So the molar mass of HX is at 60.52 gram per mole. That is the molar mass of whole compound of HX or hydrogen X. Procedure number 4, to determine the atomic mass of X in HX. So we have relative atomic mass from molar mass. The difference between the molar mass and the relative atomic mass doesn't have a SI unity within its value. So we take molar mass, we remove SI unity, that is relative atomic mass. So HX is equal to 36.52. So minus 1, so X is 35.52. So according to the value, the atomic mass of X is that one, 35.52. So according to that value represents element X to be chlorine, and that is element X, and that is atomic mass of X. So our compound was hydrogen chloride. I think now that was the end for our equation. So you are supposed to show the solution as we have been solved there in order to understand experiment even which is different from this experiment. Thank you more.